Hi guys, welcome to Practical Machine Learning series. This is an on-demand lecture on pipelines in scikit-learn. Most of the people were having issue with the pipelines, so I thought that why not create a video on that. And today we will be mainly understanding three of the important concepts of pipeline. First one being what is pipeline and where to use pipeline. I will also show you the code for how to write pipelines. Then second, we will understand what is column transformer and how we can use it with pipelines. And last, we will end the lecture with understanding feature union. So let's start today's exciting session. I hope that you will learn a lot. So guys, first thing first, why do we even need a pipe? You already know that. When we want to train our model, we split our data into training data and test data. And whatever process that we are going to do with the training data, we have to do the same thing with our test data, right? And this works very good in general cases in hackathon, but when you go into production, things goes differently. Because in production, you have multiple steps involved and you might forget to do some of the steps. So in that case, you will not get the right data. Then you will not be able to train your model and you will end up having no model at all or maybe having some issues or errors. Now think about it that if something is in production and your client depends on it, how much struggle they have to face. So to streamline this process, we use pipelines. So before understanding the pipeline itself, we need to understand how a pipeline fixes the problem. The problem here arises because we were doing the same steps again and again for our train and test data. So is there a way to fix the system? Yes, you can use pipelines to make this thing work. What you are going to do is, rather than doing it separately, you are going to create a pipeline object, which is provided by our scikit-learn. It will again take the same data. It will again do the imputation, standard scaling, PCA, one-hot encoding or encoding, and it will again train a model like train a false classifier for this case. And after that, you will do your prediction. But all things will be included inside a class called pipeline. So when you use pipeline, you will start using pipeline object, and this object encodes everything, kind of an abstraction there. But what it helps now is that you can use this particular pipeline to directly fit your train data and your test data. So this is kind of very important to understand. Now, what are the problems that it solves? A lot of them, but here are some of the key ones. First, it simplifies the workflow because you are not defining your steps multiple times. You're only using it one time and fitting the data. Prevents data leakage. So data leakage refers to unexpected input of data, and to fix that, these all steps will be performed in a sequential manner. That means first imputation will be performed, then standard scaling, PCA, one-hot encoding, everything like that. Easy model updating. Why? Because as you can see that whatever model or estimator you're going to use, you can just write a single line of code and change that model. You don't need to do anything other than that. Consistent pre-processing, this is very important. Discrepancy in training and test data poses an issue because there are inconsistent pre-processing. So to fix that, we can use the pipeline. Improve code organization. Yes, obviously, because now we not have to deal with the complexity of doing things again and again, and we are kind of reducing the redundancy of our code, as well as we are using a single object to use all the things. After that, efficient hyperparameter tuning. Obviously, some of these steps include hyperparameters. Hyperparameters are those parameters which are not calculated by the estimator. It is included by us using the trial and error method. So all you need to put is in pass this while defining your transformers and estimators. After that, we have streamline deployment. This is the major issue why you need to use this thing, because when user will input their data, all this processing will happen on the fly and you will directly get your model the right data. And after that, they will directly get the prediction. So this is how pipeline is important in our use case. Understanding this will help you understand the later sections. Now we will look at how to use pipelines and different ways in which you can combine pipelines for multiple use cases. Also, I want to share that due to time constraint, I have already written the code, but don't worry, I will explain each and everything which is required for this particular session. So let's go to our code editor. Let's start by importing library. So I will be importing Panda. Apart with that, I will be also using setConfig from Sklearn. This will be used to display our pipeline as diagrams, and I will be setting a seed for reproducibility using np.random.seed42, which is our seed value, and I will be importing pandas and numpy, spd, and np arrays. Now let's load or create data. Here I will be using a simple batch data so that it represents the real world scenario, but don't worry about all these details, guys, because these are not things that you need to worry about. Just make sure that you understand what this data is actually doing. So let me first run the cells, and you can see that here our random data is generated. All you need to understand here is that these are our features in name, balance, num, contact, and so on. And these 0, 1, 2, 3, 4 are our row indices. This target is our label which we need to predict. And as you can see, it's 0 and 1. That means we have a binary classification problem at our hand. And these all are our features that we are going to use to predict things. So we are going to get our data. Here, as you can see, I am importing train test split from sklearn.model selection class and taking the y value as target and rest of the values as features. So x represents our feature and y represents our target. These extra brackets represent 2D array. After that, we are setting our train and test split, and we are splitting our data as 20%, and we are setting the random state as 42 for reproducibility. Also note that x train and y train are training set, x test and y test are testing set. X train refers to the feature column and y train refers to the target column or the labels column. Okay, and here I have printed the shape. As you can see, our X train has shape of 80 rows and 5 columns. Y train has only 80 rows because it's a series. Now let's start using pipelines. Okay, so you can read all these. I will be providing notebook later. The main focus here is that you need to understand how you can use pipeline. So using pipeline is very simple, guys. You need to import pipeline from sk.pipeline module and define your steps. These definition of steps are important, and here you will be giving list of named tuples, and the format is the processing name, the processing function. Processing functions means if you are using standard scaling, then standard is scalar, one hot encoding, then one hot encoder, whatever function you are going to use. And similarly, you are going to do in the other term. Now, these are separate steps that you need to define here in this. And after that, you will be just using your pipeline and passing in the steps, that is the list of named tuple, and renaming it to pipe. That's all. So that's what we are going to do here also. Here we are taking an example of a standard scaler with a logistic regression, which is a very simple use case. First, we are scaling our data and then we are applying logistic regression. So here you can see that I have already defined my steps. First, preprocessing name is scalar, and second is the function standard scalar. And after that, we have used our logistic regression. Now, if you see, I have set it pipe now. Reason, because these all steps can only be performed on a numerical data and categorical data we can't. So try to name them separately. It is very good practice. After that, our estimator had this dot fit method. Since it is the last step of this particular pipeline which we have defined in our step name tuple, the general steps are you can define as many processing functions as you want. And after that, at the last, for using fit and predict, you can define your model. So here we have just used the name of the pipeline, then dot fit our training data like training features and training levels. After that, we are printing the pipe. Now you can see here, this is the entire thing which is created. So pipeline, it simply says whatever steps we are going to perform. So first we are going to perform a standard scalar, and then we are going to use logistic regression. Now you might be wondering, I have said earlier that we are going to visualize it. Yes, obviously we are going to visualize. I just want to make a point here that if you use print, you will get this particular name. But if you don't use print in your Jupyter Notebook or Google Colab, you will get this. And now you can see that if I expand this pipeline, you will get everything. As you know that our model is trained, we can predict our answers on our test data. That means that we can use the predict method on X test. Obviously, it will take only X test, not Y test. Make sure of that. And we will store our results in Y-print. Now, if I run this, you will see that I have an array of 0 and 1 that it has predictors. That's super easy, guys. But now let's make it a little bit more complex. So oftentimes, you don't only have your numeric data, it contains your categorical data, and it is better to process all of them together. So scikit-learn provides us a column transformer class that can be used here. Column transformer allows you to transform your data based on the column names or column indices. And the required format for data is kind of similar, just that here, rather than just 2 values, we are passing 3 values. Name, whatever operation or processing function you want to apply. After that, name of the columns or indices of the column. So this is very important because it will help a lot in later use cases. So here again, we are having an example. We will be using one-hot encoder, PCA, and standard scaler for our word case. And as you know that one-hot encoder is for categorical data. So first we need to split our data. So I have splitted the data in numerical features and categorical features. All I am doing is I am selecting whatever column names are required so that we can use it later. And it's a good practice as a beginner that you try to do these things so that things remains very clear and easy to understand. After that, we are going to again take our X and Y values. The Y will be our labels and X will be our features. Again, we are going to do the train test split using the same or default settings. As you remember, earlier in the steps, we used this particular method where we used bracket also. Don't use bracket for column transform, because column transformer just takes in tuples and it expects us to put our values in list. So we are only going to pass the tuple. Since it is a numeric, so I was saying num and then standard scalar. Obviously, you can do a scalar also. And then numerical features. Now remember, numerical features was set of all the columns which has numerical values. Same thing for categorical pipeline. Name is cat. One-hot encoding will be implemented on these categorical columns. After that, we also have our PC. Now this PCA, we can't include it here because sequentially things will go. So if we do our PCA here, that means that all the numeric operation will be performed. But as you know, till now we haven't completed our categorical processing, right? So in that case, it will cause an error. So make sure that you understand this particular thing because it's very important. After that, we are defining our preprocessor. Obviously, it can be called anything. And then we are doing column transformer and num pipeline, cat pipeline, and PCA. Now, this is a standard way to write these pipelines, but you can directly copy this and put it here. And again, you are trying to copy and doing the same thing. After that, we have our steps. These are for transformations and time-sensitive reduction techniques. But we need our model as well. So we need to do certain processing on that, right? So for that, we are kind of defining our steps like we did in the earlier section also. Just that here we have our column transformer included in our preprocessor. So we are directly using preprocessor, then we are passing preprocessor. Obviously, we will be using preprocessor to access the name. And here you need to understand one thing. You can't directly access the num and cat now. You need a specific way in which you can access num and cat. I will be explaining it later. Now, once you have a preprocessor in your tuple, then you are going to pass the logistic grid. Now, after that, since this is a column transformer, so I have named it pipe city, whatever you want, you can name. And I have said pipeline step. And now if I print the pipe city, you can see that we have our pipe. So it says standard scalar, categorical, that is one-hot encoder, and then PCA. And after that, all these are combined and passed to logistic regression. You can see what is going to happen here, right? So this is one of the benefit of using column transformer and pipeline together. And we are going to fit our model. So as you know that we are having our model as our last step. So we are going to use our model. So fit X-train, Y-train, that means our training features and training labels. Once we are doing that, model is fit. If I do the test, you can see that again, it has predicted some of the values using logistic regression. And if I want to check the score, so you can see that model is 40% accurate. So this is the pipeline using column transformer. After that, we are going to use feature union. Now comes the feature union. So feature union is not commonly used, but allows you to run transformation in parallel. As you know that earlier when using our column transformer, we were not able to use our PCA with numerical feature, though it was applied on numerical feature later. Because this pipeline works sequentially and it will not take data independently. But our feature union allows us to take our data independently. It takes a list of transformer adjust and fit the data according to it. It runs very fast compared to pipeline because it runs parallel. Now, the steps to use feature union are kind of very simple. Again, you are going to import your feature union from your Sklearn.pipeline class. After that, you are going to use feature union and pass a transformer list. And these lists will be nothing but a list of named tables similar to whatever you have defined earlier, just that here whatever data you are going to put, it will be running in parallel. After that, store it in the variable. I use fu. After that, you get print your variable. Unfortunately, I don't have the right data right now to explain you how it works using code. I will try to come up with a feature union specific video later on. So I hope that you understand this particular thing. Now let's move on to our resources. Resources is very simple. You can learn more at the feature union Sklearn pipeline and see there are a lot of them which are very useful here to use. And after that, we have our GitHub notebook, which is the repository where I am uploading each and every lecture's video, and you can directly use the name or find it and practice along. Apart from that, you also have the series playlist itself where all the videos are sequenced and try to carry out everything. After that, we also have the image which I used earlier, so you can directly access it, right? So these are very important things. Make sure that you understand this. So guys, that's it for this particular video. I hope that you understood what pipeline is, how we can use pipeline, how to use column transformer with pipeline and feature union. I hope that you will apply it in your workflow and be more efficient with it. So I will meet you in another video. Till then, bye-bye.